Hello and welcome to module 4 of our Exploit Development Basics series. This module is about ASLR bypass and stack pivoting techniques. So these are the few things or software that I'm assuming that you as a learner have a basic knowledge of. If you don't, or if you want to learn them from scratch, please check out the resources mentioned at the end of this video. This is our module structure. Our module is divided into 6 parts, that is introduction, fuzzing, POC creation, controlling the execution, bad character analysis, and finally cracking the shell. We are on the first part, that is introduction, wherein I give you a brief overview of the technique that we will be using in this video and the tools required for this module. Following are the tools required for this module. We'll need a virtualization software. You can use either VirtualBox or VMware. We'll need two virtual machines, a Linux box and a Windows box. For Linux, we'll be using Kali 2018.1 as a VM, and on that we'll need Python 2.7 and a text editor. You can use either Sublime Text or Notepad++. On Windows machine, we'll be using Windows Vista 32-bit as a VM, and we'll be using following software, that is FileFuzz for fuzzing, Immunity Debugger for debugging the application, Mono library for Immunity Debugger, and our target software will be Cool Player Plus Portable. And again, we'll need an editor on the Windows machine as well. You can use either Sublime Text or Notepad++, and we'll need Python 2.7 installed on this Windows machine. So allow me to give you a brief overview of what is ASLR, or Address Space Layout Randomization. It is a memory protection technique to avoid memory corruption exploits. It was developed by Microsoft and it has been implemented in Microsoft Windows operating systems, Windows Vista onwards. So basically, it randomizes the base address of memory segments such as the stack or the heap. As you can see from the example here, I have two screenshots from Immunity Debugger in which I am running Internet Explorer. So in the first instance, as you can see on the left here, the memory address starts from 770B0F and 48. And if you come on the screenshot on the right, it's again the running instance of IE Explorer. This I created after restarting Windows Vista. And here, if you see this address 77DD0F08. So in both these screenshots, the second byte here is different. So in here it is 0B and in here it is DD. Now every time the operating system is started, this base address gets randomized. But there is a way to exploit it, which we'll cover in a while. Now, in order for an application to be ASLR enabled, it needs to be compiled with dynamic base option. Now, most operating system DLLs are ASLR enabled by default. Now, what are the techniques to bypass ASLR? There are a couple of techniques that can be used to bypass ASLR. First is using non-ASLR enabled libraries. So usually it happens that when an application is developed, the exe and the associated DLLs might not be compiled with the dynamic base option. In this case, while OS DLLs are ASLR enabled, the application binary and its associated DLLs are non-ASLR enabled libraries. Our second technique is partial byte overwrite. So if I go back to the slide here, in here we can do a overwrite of these two bytes, and we'll design an exploit in such a way that the application supplies the randomized bytes. So this is a technique that we'll cover in the later module. The third technique is brute forcing the address space, wherein you design your exploit in such a way that it tries to guess the randomized address. So it's more of a trial and error method, and it has a huge overhead in terms of size, and it might also lead to unstable exploits. There are a few more techniques to bypass ASLR, which we'll cover in one of our later modules. Another technique that we'll be learning in this module is stack pivoting. Now, stack pivoting basically means that you point the stack to an attacker control buffer space. Now, at times, there might be situations wherein you need your exploit to do certain operations on the stack. For this, we'll need the control of ESP, that is a stack pointer. Now, let's assume that this is an application stack and this is the current ESP position and this is our attacker on buffer space. Now, we want to do certain operations here, but since our ESP is pointing at this address, we won't be able to do that. So in order for the attacker to do operations here, we will need to shift the ESP pointer to this space. That is what we do in stack pivoting. We change the stack position from this space to our attacker owned buffer space. We do certain operations and then we restore the ESP to its previous place. This sounds more complex than it actually is, and you'll see that in later videos of this module. So these are the few resources that you can use to learn more about the software or techniques that we are using in this module. Thank you for watching this video, and I'll see you in the next part. Meanwhile, please subscribe to our channel Yakshas CSC and follow us on Twitter. Our Twitter handle is @Yakshas443. And if you need files or PDF slides for any of our previous modules, please drop us a mail at csc@yakshas.in.